Good evening, ma'am.
Mhm. Ready, students? I can see students. Your video is off. Please turn on your videos. So today we are going to start electric current and its effects.
Ma'am, we are done with the
Ma'am,
chapter.
we're done with this chapter.
Entire chapter completed.
Yes, ma'am.
ma'am.
1 minute, students. Yeah, no problem. For this week, I'll be there with you for 1 week. Later, your mom will join again. Okay, so we can discuss again the same chapter. Electric current and its effects.
Ma'am, should we also write what are you writing right now?
You can simply listen.
Okay.
Okay. So what is electric current, students? What do you know about a current?
Current is a flow of charged particles.
Okay. Charged particles. So which particles are those? Which particles? You are telling charged particles, charged particles. It means the particles whichever have charge are called as, like the flow of those charged particles is called as current. But what is that name? Name of the particle which is having charge on it. So what charge it is? Anyone? Anybody?
Ma'am, the electric charge flows through a conductor.
Yeah, flow of electric charge. So you're telling there is a charge, right? So the charge is due to. So we can say nothing but the flow of charged particles, and those particles are nothing but your electrons. Okay. Electrons. So what are electrons? Which charged particles are
Ma'am, your
electrons?
voice is low.
1 minute, let me correct. Fine now. Students, am I audible?
Yes, ma'am, but then it's still low.
Still low. Now, is it clear? It's fine now?
Yes, ma'am.
Okay. So the flow of electrons is called as, that is, what is the charge of electron? So what charge it bears? What charge electron bears? Anyone? Anybody? So electron has a charge which is a negative charge. Isn't it a negative charge electron carries? Yes?
Yes, ma'am.
Okay. So we can simply say that the flow of electrons, okay, it is a path. So you are telling about a conductor, in a conductor. So what is a conductor?
Conductor is something that allows electricity to pass through. For example, copper, it's used in electrical wires.
Yeah, perfect. So mostly the metals. So metals are good conductors of electricity. So almost the most of the metals you can see that electrons pass through it. So because of that, electricity is, you can see electric current is produced. Okay, clear? Clear with the definition of electric current?
Yes, ma'am.
Next, coming to the circuit, electric circuit. So how we are going to identify an electric circuit? What are the components it is going to have? Okay, so electric circuit, to make an electric circuit, the component need is, first one is source of electricity. To make a circuit, you need certain resources like source of electricity. How you are going to give electricity? So you are telling, so you will pass current through conductor, then only electrons can flow, right? So what is that source we are using? So the source mostly we use is cell. It can be a cell or a battery. Okay, so how we are going to identify a cell? Cell is a source of electricity. It has two terminals. One is positive terminal, another one is negative terminal, right?
Yes, ma'am.
So whenever you take a cell will have two ends. One end is shown with a plus symbol and another end is shown with minus symbol. Next, coming to the battery. So what is battery?
Ma'am,
Battery is a
group of
combination of two
cells.
or more cells.
Yeah, very good. So we can say combination of cells. Okay. To make a circuit, we need a battery. We need a source of electricity. So that is a cell and a combination of cells, which is a battery. Okay. So to make a battery, we need cells, right? So how we are going to arrange cells to make a battery? So we can arrange cells in a series manner or in a parallel manner, or we can say side by side manner. Okay. So generally, what is a cell? So whichever you used in remotes, in the regular use at your daily use at your homes, so which is having plus and minus symbol on it, so this is a cell. Okay, if these cells, if you are arranging in a series, so in series how you are going to arrange? So with the opposite terminals are going to combine here. Okay, plus minus. Okay, this is the way of making a battery. You can combine cells in a series manner. Next one, in the side by side manner. So this is the plus, you have minus here.
one plus minus here. So in side by side manner, you can see that opposite terminals are connected like this. Okay. So from this, what it is clear that always we need to what is the note we have to remember here? Always connect positive with negative terminal. Okay, always we have to connect a positive with negative terminal, that is opposite terminals. Clear with the source of electricity, students? So source of electricity is we can use a cell or we can use a battery. Okay, the cell is the one which is having positive and negative terminal, whereas battery is the combination of cells. So we can make a battery either by combining cells in series or in parallel manner. Next one, to make a circuit, the other one which we need is switch. Okay, why switch is used? Switch is used to control the flow of electricity. Okay, to control, what is the use of switch? To control the flow of electricity. Okay, next we need a device. So what is that device? Device is the one which you need to work. So to this device we are connecting the cell and we are connecting the switch. So device can be your TV or it can be your bulb or it can be any motor, etc. Okay, next one, for the connection we need wires. Okay, how wire is used? It is used to make connections, like used to connect various components. Used to connect various components in the circuit. Okay, clear?
Yes, ma'am.
So now we will see how all these are shown in the circuit. So generally, how a switch is shown, how wires are shown, like how a cell is shown to make a circuit. Okay, so consider component on one side and symbol on the other side. So cell is shown in the form of plus and minus terminal. So this is the symbol, so which we need to identify. And battery. So what is battery? Which is a combination of cell. So we can see a combination. Okay. Next wire. Wire is shown in the form of a single line, the solid line. Next switch. So switch is shown in two different symbols. That is, if switch is on, it is shown with one of the symbol. If switch is off, so switch on means it is shown like this. That is, both the two ends are connected and there is a flow of electricity in between them. If switch is off, so the ends are not connected. So you can see how it is open and there is no flow of electricity from this end to that end. Next, bulb. So bulb is shown in this manner. Okay, so these are certain symbols which we use to indicate the components of the electric circuit. Clear, students?
Yes, ma'am.
Yes, ma'am.
So So I hope everything was completed earlier, right? To know all these.
Yes, ma'am. The whole
Yes,
chapter
ma'am.
is done.
So how to make a circuit? We can see the diagram. So a cell, consider a cell. So this cell is connected to a switch and further to a device. Okay. So this is the way. Now can you tell me in this particular circuit the switch is in on position or off position?
Ma'am, on position.
If switch is on, the bulb should glow or not.
Ma'am,
It should glow.
Yeah, so bulb should glow. I'm showing like this, the glow of bulb.
Ma'am, and the arrows should be marked for the flow of electricity.
Okay, so in which direction we can show this?
Ma'am, from the positive terminal.
This?
Yes, ma'am.
Yes, ma'am.
So what about this? This is no?
No, ma'am, because electricity flows from negative to positive.
Yeah. Negative to positive or positive to negative?
Oh, positive to
Positive
negative.
to negative.
Yeah. So when filament is break, in that case the circuit is said to be incomplete. So what is filament?
Ma'am, the thin layer inside
Right?
it.
Yeah, this is the filament. So if filament break, circuit is incomplete. Circuit is incomplete. Then no current flows. If current doesn't flow, then no glow of bulb. So bulb will not glow. Okay. So the bulb, whatever the bulb with the fused filament, okay, with a broken filament, it is called as which bulb, students? The bulb with broken filament is called as bulb with broken filament is called as fused bulb. Okay, so bulb with broken filament is called as fused bulb. Clear? Clear so far? Clear, students?
Yes, ma'am.
Okay. Let's see what are the effects. So effects of electric current. So what are the two effects of electric current? So one is
Heating effect and magnetic effect.
very good. Heating effect. Next, magnetic effect. So heating effect is when an electric current passes through a wire, it gets hot, like it produces heat. Okay. So what is heating effect? Because of flow of electric current, when an electric current passes through a wire, it gets hot and produces heat. So yeah, we are telling it is producing heat. How can we use that heat? Okay, what are the various ways we can reuse that heat? Uses of heating effect.
We can use it in a electric heater, and it's also used in a light bulb
Hmm.
and hair dryers also.
Okay. What about electric fuse? So you already mentioned too, that is electric heater. Because of this production of heat, the coil of the wire becomes red hot and it produces heat. So that is the first case where we can use this particular heat in a electric heater. Next we can use in lightning bulb. Okay. Third we can say we can use in electric fuse. So which works again on the principle of heating effect of electric current. So it is a safety device that protect devices from short circuit or damage. Do you know fuse? Have you ever seen fuse in the meters of your home? If fuse is lost, you can see power is off. So why fuse is used? Fuse is used, it is actually a protective device. Prevents from short circuit. So this particular electric fuse also works on heating effect of electric current. So do you know what is short circuit, right? Everybody knows short circuit. So when too much current passes through a fuse, the fuse wire heats up, it melts, and it breaks the circuit. When too much current passes through a fuse, the fuse wire heats up and melts, breaking the circuit. Clear? So we can say fuse is nothing but a wire. It is nothing but a small wire which has low melting point. Okay, if it receives too much of current, then only it melts. So a fuse is basically a wire with low melting point. Is that clear, students? Clear so far?
Yes, ma'am.
Okay, so how much amount of heat is produced from the heating material? Amount of heat produced. How can you say that? Due to heating effect, how much of heat is produced? We are telling because of heating effect, heat is produced. So how much of heat is produced? So that completely depends on, on the material of the wire, depends on the material of the wire. Next, it depends on length of the wire. Next, and on the thickness of the wire. Okay, so whatever the heat is produced, that heat is totally depend upon the material of the wire, length of the wire, and thickness of the wire. Clear? Clear so far with the heating effect. Next is magnetic effect. Okay, whenever, so why a magnet introduced? Like why the term magnet was introduced in the chapter of electricity? So we are talking about a circuit, a device, current, wires, and everything. So why a magnet is introduced? Why the term magnet is used? Do current involves in producing magnetic power? What do you say, students? Why magnetic effect was studied here?
Because electricity is required to make an electromagnet and it's used in devices like electric bell.
Yeah, because of that effect only we are using an electric bulb. So, but why we are learning about magnetism, like magnetic power, magnetic, why this particular term we are studying? What's the reason? Because whenever a current is passing through a wire, it behaves like a magnet. So whenever you can, if you sprinkle like a small iron, like a small iron, what do you say, like crumbs, so it will easily attract. So we can say that whenever a current is passing through a wire, it behaves like a magnet. So when electric current passes through a wire, it behaves like a magnet. Clear?
Yes, ma'am.
So where we can use, so in which devices we can use. So one is electromagnet, next one electric bell. Okay, so what is electromagnet? Electromagnet is a type of a magnet that is created by using electricity. It is a coil of wire which is wrapped around iron that becomes magnet when current flows through it. So in electromagnet, we can see a iron nail is there, around iron nail. So we generally take iron nail. So around the iron nail, so so a wire is wrapped. So coil of wire is wrapped. There. Okay. Now this is connected to a circuit. Okay. How can you say that the like magnetism was developed here? Magnetic property was developed in the iron needle. So we know that we are passing current through the wire. So if current is passed through the wire, then this iron nail behaves like a magnet. So how can we say that if you take any iron particles, like I'm taking pins, any needles or pins, so it will attract. So this thing is going to attract. So if switch is on, the current flows through the coil. Coil behaves like a magnet and pins actually cling with the coil. If switch is off, no current flows through the coil. Coil loses its magnetic behavior. Okay, clear with this point?
Yes, ma'am.
Yes.
Next, coming to the electric bulb. So what are the main parts of electric bell, students? Electric bell.
Ma'am, one of the most important stuff or the component for the electrical bell is the electromagnet.
Very good. Electromagnet. Electromagnet is nothing but again a coil of wire which is
Wrapped around a soft iron core.
yeah, which can become a magnet when
And ma'am, it is better preferred than a permanent magnet, as it can, you can control the magnetism in it, and it is not a permanent magnet too. It
yeah,
can be controlled, the magnetism. The
yeah,
more times we wrap the coil around the soft iron core, the stronger it becomes.
yeah, very good. And other parts, main parts,
Ma'am, the soft armature and the gong, the battery or cell, switch,
very
and the connect or the and the connecting wires.
okay. What about hammer?
Yes, ma'am. Oh, yeah.
There should be a hammer, then only it can strike the gong to produce a sound. So these are the main parts. Okay, what are the main parts? First, gong. So gong is nothing but a metal part which produce sound.
Yes.
Okay, so how it is producing sound? Because of the hammer which is striking the gong. Because of hammer strikes the gong. So because of which you can see the sound is produced. Next one we can see electromagnet. So what is electromagnet? Which is a coil of wire which can become a magnet because of passage of electricity. Okay. Then we can also see a button or a switch. So when switch is on, electricity starts flowing into the electromagnet. The electromagnet behaves like a magnet and it attracts the soft iron attached to the hammer. This hammer, which is going to strike the gong. So what is happening first? When switch is on, electricity flows into the electromagnet. So if magnetic property is generated, then this can act like a magnet and it attracts the soft iron attached to it, behaves like magnet, attracts soft hammer, soft iron attached to the hammer. Okay, next hammer strikes the gong. Because of which sound produced. So if a hammer strikes the gong, the circuit breaks or not. If hammer is striking the gong and sound is producing, then what about the flow of electricity? It will be still there or it will stop. What, please answer students. When hammer strikes the gong, what about the flow of electricity? It will be still continuing or it will stop?
It will stop.
It will stop because the circuit breaks. As the circuit breaks, current stops flowing. Okay, because of which electromagnet loses its magnetic behavior. Loses its magnetic behavior. If electromagnet loses its magnetic behavior, it no more attracts hammer. So because of which hammer return to its original position. Return to its original position. Clear? How the electric bell is working? So when switch is on, electricity flows into the electromagnet. The electromagnet behaves like a magnet then. because of which it attracts soft iron, which is soft iron attached to the hammer, and hammer strikes the gong, because of which sound produced. When hammer strikes the gong, the circuit breaks, current stops flowing. Electromagnet then loses its magnetic behavior, and finally hammer return to its original position. Okay, if hammer return to its original position, then again circuit is completed. Again circuit is completed, and some process is repeated quickly again and again, and some process is repeated quickly again and again. Clear with the working of electric bulb, students?
Yes, ma'am.
So
Yes.
diagram, you are going to have electric magnet. Around the electromagnet, you are going to have a wire wrapped. Okay, so to the one end a gong is attached, and it is attached to switch on one side, and then a cell. This is the hammer. This is a gong. This is soft.
Ma'am,
Yeah.
ma'am, I actually have another class. Can I leave?
Soft. I think we are done with this class, right?
Yes, ma'am.
Yeah. This is the soft iron piece. So this is attracted towards electromagnet, because of which hammer strikes the gong and it starts producing sound. Clear with this electric bell, students?
Yes, ma'am.
Okay, then we can meet in the next class, students. So you have another class now? Everybody or only she?
Ma'am, only I have. I have another class from outside.
Okay, you can do. Okay, students, we can end the session for today. Let me know if you have any questions about what we discussed. Anyone?
No, ma'am.
No, ma'am.
I hope everything is clear from my side.
Yes, ma'am.
Session for today. See you.
Thank you, ma'am.
Bye. Bye.
Thank you, ma'am. Bye, ma'am.